Okay, here we are back at the question 5 this time of the 2021 Specialist Maths Exam 1, VCAA. All right, so in this particular one it says find the gradient of the curve with a particular equation at a point. So gradient means dy dx. So we want to initially, we know, because when we've got the equation, we need to differentiate it and then do a substitution later. But first of all, we're going to differentiate it. Now, when you have a look at the equation here, you see that it's reasonably complex. It's not in the form of y equals, and so it's actually got y in this term and y in this term as well. So what we're going to need to do is implicit differentiation. All right, so what did I say we're after? We're after differentiating this equation. To e to the 4th. There we go. All right, so we want to differentiate that first of all. So we're going to have to use, as I said, implicit differentiation. All right, so in the first term here, it's actually, we've got the product. So we're going to do the product rule on this first term. So product rule on this first term. So derivative of that times that plus the derivative of that times that. So derivative of e to the x times e to the 2y plus the derivative of e to the 2y times e to the x. So derivative of e to the x is e to the x times e to the 2y plus. All right, now we will need to, well, e to the x is still going to be there, but we now need to differentiate this bit here. All right. But this is in terms of y, not in terms of x. So we've got to differentiate that in terms of y. And so when we do that, you get 2e to the 2y. But gradient's dy dx, and we've differentiated with respect to y here, so we need to follow with the implicit differentiation times dy dx. Similar with this term, the derivative of that is 4e to the 4y squared times 2y times dy dx. All right, and the 2y comes when you differentiate with the y squared. So I've done it in a bit of a strange way. Now this bit here, 2e to the 4, e to the 4 is just a number, right? So e is a number, and to the power of 4 gets a number. So when you differentiate a number, you get 0. All right, so what I'm going to do now is I'm going to say we've got e to the x, e to the 2y, plus now these other two terms have got dy dx as common, so I'm going to put dy dx there. And with this bit, I've got 2e to the x, e to the 2y. And this other term, I've got 4 here times 2y there, so that's 8y, e to the 4y squared equals 0. All right, so now it asks us to find the gradient. So It doesn't ask us to find an expression for dy dx, it just asks us to find the gradient. So what I'm going to do is to save some work and some manipulation. I'm just going to substitute in here. So at 0.21, substitute in for x is 2, y is 1 into this equation as it stands here without rearranging it. We may need to then rearrange it later, however, but let's just see what we get. So what do we get? We get e to the 2 times e to the 2y, 2 times 1 is 2, plus dy dx, 2e to the 2, e to the 2, plus 8 times 1 times e to the 1 squared is 1 times 4 equals 0. All right, so what do we got here? E squared times e squared is e to the 4 plus dy dx, 2 lots of e to the 4 plus 8 lots of e to the 4, and that equals 0. So we've got e to the 4 plus dy dx. Then in this bracket we've got 10 lots of e to the 4 equals 0. All right, so now we're going to have to rearrange from here because we're asked for the gradient, which is dy dx. All right, and so it's going to be a lot easier to rearrange with these terms than it was with all of that stuff up there. All right, so I'm going to take e to the 4 from both sides, and so you've got dy dx then times 10e to the 4 equals negative e to the 4, and then we need to divide both sides by this bracket 10e to 4, so dy dx is negative e to the 4 over 10 e to the 4. The e to the 4's cancel, and so we get negative 1/10. So the gradient of the curve at 2, 1 is negative 1/10. All right, so there's a bit of working going on there, which is all right because it's worth 3 marks. So you need to show a bit of working to get all your 3 marks. Personally, just to be sure, I'd just make that statement there, just in case. But there we go. So implicit differentiation, you can almost always count on a question on implicit differentiation somewhere or other in one of the exams. All right, so question 5 done. Next question 6 will be on its own video.